So this is a sample question that is very similar to Leaving Cert question. I'm not too sure what year it came up, but it is very similar to this, and I've changed around the numbers a little bit. So they're giving you a picture of the eye, and they are basically doing two things here. They're telling you that the length of the eye is 1.8 centimeters. So this here, 1.8 centimeters from the lens. That's the distance from the retina out to the lens. Now, if we think about what we want the eye to do, we want the eye to focus an object onto the retina. So this is like the screen. So that distance between here and here, they're telling you that that's 1.8 centimeters, but that's going to be your image distance. That's going to be V in any calculation that you do. The lens system contains the cornea, which is a fixed lens at the front, and that is given, you're told the power of this here is 40 per meters, 40 diopters, okay? It is a variable internal lens, and that's grand. Now, the reason I've given you this question is there's quite a lot of information that they're throwing at you at the start here, and it's very, very important that you are able to make sense of it. And the best way of making sense of that is to draw a diagram. Now, I'm giving you a diagram here, but there is a very good chance that they won't give you a diagram in the exam. So that's the first thing that you need to do, is put that down. And they give you this other piece of information here, that the maximum power of the eye is 66 diopters, okay? And that's just left there. So we're kind of wondering, okay, what am I doing with that? So the two things they ask, how near an object can be placed in front of the eye and still be in focus, and the maximum power of the internal lens. So let's look at the first one. If something is still going to be in focus, then what we are basically saying is the relationship between between the object distance u, between the image distance v, is going to follow this. 1 over u plus 1 over v is equal to 1 over f. If your object distance and your image distance fit in here, then this is going to be the focal length associated with that. Now, our focal length here is fixed, okay? And it's fixed by the power of the lens that you have. So their question is, what's the nearest? How near can an object be? Now, the nearer the object, the more powerful you want the lens to be. And they tell you down at the bottom here that the maximum power of the eye is 66 per meter. So that's the first place that you're going to start with. If you know that your power is 66 diopters, then your focal length is 1 over 66 as opposed to 60. 1 over 66, which works out at 0.01515. Okay, now that's in meters. I like to work in centimeters because everything else is given to you in the question in centimeters. So change that and you get 0. No, sorry, you don't. You get 1.515 centimeters. Okay, now try not to round this too much. Keep 2 to 3 decimal places definitely in this. So that's your focal length. Right, so when this lens in here is acting, when that's at its maximum, it's acting with its full power, then the combination of the cornea and that lens are going to give you a focal length of 1.515. Okay, so what you have to find out is, well, what's the size of or what's the value of u that's associated with a focal length of 1.5 when I have an image distance of 1.8 centimeters. Because remember, that image distance, that can't change. That's always going to be the same. So what is happening as you are bringing an object closer to your eye, you're changing u, and therefore to balance out this equation, you have to change f to keep that in balance. So that's what your eye is doing. It's stuck with a fixed image distance. It changes the focal length of the lens so that you still have a clear image when you change the object distance. So that's all you're doing here in this part, is using that formula. 1 over u plus 1 over v is equal to 1 over f. It's definitely positive because it's always given, you have to have a real image basically in here. Your eye never is in the position of where it gets a virtual image, because if you don't have an actual image projected onto your retina, then you don't see what you are seeing. So let's fill in what we know here. Now, this is where we need to go back to our question. So this 1.8 centimeters here, that is our image distance. So that goes in down here. So we have 1 over 1.8. We know the focal length, 1 over 1.515. So you'll notice that both of these measurements are in centimeters. So that has to be the case. And then what we don't know is the object distance. So 1 over u plus 1 over 1.8 is equal to 1 over 1.515. When we do this calculation, we get 1 over u, and I think I got something around 35 over 342, and that gives you u then as 9.77 centimeters. Okay, so that's the closest that you can bring an object to your eye without the image getting blurred. Okay, so again, if we put that into our diagram up here, where is our v going to be now? Again, our image distance is going to be out here. Okay, so you're going to bring your object, and use our nice little stick, to the front of the eye here, 9.77 centimeters away. Now, just to recap, when you are given all these pieces of information, it's not always the case that you're going to use all the numbers that they're given for the first parts, but you will use all the numbers that you are given at some point in the question. And if you're not, that's generally a bad sign. So the other part of the question is the maximum power of the internal lens. Okay, so come back here to what we're dealing with. We have two lenses. We have your cornea, which I'll label as C, and we have our internal lens, which I'll call L here. So those two lenses we know have a maximum power of 66 per meters. So if we write that out here, we know that P1 plus P2 is equal to 66 diopters, right? 66 per meters. Well, they've given to you in the question that this internal lens, the cornea has a power of 40 per meters. So we know that P1 here is 40, plus the internal lens, we don't know the power of. You add that together and you get 66. So that gives you P2 then is going to be equal to 22 per meters. That's it. It's as simple as that. This catches so many people, okay, that it's the way that the questions are phrased, the maximum power of the internal lens. Well, you're told the maximum power of the eye is here, so that has to be the power of the cornea and the lens put together. And they will always give you one of those, or you'll have had to work it out from one of the parts up here. That's it. I will leave it there. And again, just if there's anything to take from this, it's just the numbers that they give you. Just make sure that you understand physically what's happening with those.